Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aksal Hammam, and I am from class Numeric Method 02. So today I'm gonna explain about, um, in short terms, about my answer in final exam or in final final exam for numeric method. So the first question is about self-evaluation or muhasabah. So I will explain all of this my writing on my final task paper. In I will explain it briefly or in short terms. So if I will rate myself um, in a range of 0 to 100, I will rate myself in 75 out of 100 score. So the reason why I rate myself like that is because if I take a look at my performance in how much video or challenge I made and I compare it to my friends' performance in making video and making challenges like that, I will see that my performance is between good and bad. So it's like in the middle. And for evaluation, I made 7 videos, which in quantity isn't that bad compared to some of my friends that um, they have some of my friends have less than 7 videos. Also, if I see the quality of the video, it's not that bad. It's not that bad either because I'm quite intent on making those videos. Like um, before I'm making the videos, I will make some preparation, like making PowerPoint, etc. etc. Also, if I see myself on performance during class, I only miss class once and I never late for attending the class. Also in class, I'm trying to stay conscious as long as possible. The reason I'm trying to stay conscious is because um, in class, I really want something from that class. So my time on that class is not useless. So with this evaluation and after careful consideration, I think I will judge myself with score 75 out of 100. So that is my self-evaluation or muhasabah. So the next thing is intention, right? So actually the intention is we have me and my friend have already done that in class with reciting ayat kursi, istighfar, and grants to Allah. So in this final exam paper, in a I will write it brightly. So there is two intention here. We got a long-term intention and short-term intention. So for the long-term intention is, of course, um, God is we are something that God's creation. So we're gonna in the final we are gonna meet God. So the long term is we're gonna enter God's heaven, and in short terms is we're gonna solving the problem below. So for my final exam, I'm gonna try to um, I'm gonna try to answer the first problem in for PDF that Mr. Dai has given me. So the intention, I mean the problem here is divided into three A, B, C. So the first is to determine the critically damped value for each socks, and B to solve the spring mass system for each sock with given damping value, and plot the solution. And last is to discuss the model of each sock with regard to the satellite being placed on the trailer. So our intention is we're gonna um, solve this problem So that is for our intention. So next is the initial thinking. So in initial thinking, we're given a specification of each shocks. So there are for air coaster, we got the spring constant of 220 and damping coefficients or beta of 100. And for cloud riders, we got a spring constant of 59 and beta or damping coefficient of 1050. And for extreme shocks, we got a spring constant of 170 and damping coefficient or beta of 1110. So that is for initial thinking. Oh yes, we got more on initial thinking. So this is modeling on initial thinking uh, springs that attach to a mass, and then we got also the differential equation here on initial thinking, given on the problem below. Differential equation simplified suspension system we have according to m, that is mass times two times derivative plus beta times derivative and plus k times x or displacement equals to function of t, where xt is the displacement from the stationary position in matter, m is the mass, like I just said, beta is the damping constant, and k is the spring constant, and ft is the external force in Newton. And this we also know that the suspension system for the SCTS needs to be fit with cost-effective shocks that are reliable and protect the satellite while being loaded and transported. And we also know that trailer will be loaded with satellite with mass of 1,800. So we also know the mass. Also, we also know on the initial thinking that we are assuming that the loaded trailer is at equilibrium. The displacement of the shocks before the trailer loaded is 3 centimeter. So we also know the displacement for the shocks before the trailer loaded. So how do I find those initial thinking? So this I find on the first question, and also I find it in this PDF before the problem. So that is for the initial thinking. So next is we're gonna go to the idealization. So here is the idealization. So with variable known initial thinking, like mass, damping coefficient, displacement, and etc. So we can use some formula to answer the problem. So first is we got formula for C critical that equal to 2 times root of K times mass, where the K is the spring constant and M is the mass. And next is for our coaster, we got so this um, this formula is for solving the B problem, for plotting the solution and uh, solving the spring mass system. So we already got the um, the spring mass system for each shocks. So here is xt, where x is the displacement, equals to e um, minus c per 2m times a cos omega dt time plus b sin omega dt, and for cloud riders and for extreme shocks. So next is we're gonna go to instruction. So first is A is we're gonna calculate the C critical with um, the formula here, where C critical is equal to 2 times root K times mass. So we can determine the critical for the SOX for air coaster. We already know that K is 220. So we got air coaster for C critical is equal to 1260.9, and for cloud riders, where the constant spring is 59, so we got uh, C critical that equals to 652.9, and for extreme shocks, uh, we got spring constant of 170, so C critical is equals to 1106.8. So that is for first problem. And next is to plot uh, each shocks, um, for plotting for each shock. So actually, for plotting these each shocks, I'm using Python to solving the this for each shocks. So I'm using VS Code for solving this equation. So first is we're gonna solve for air coaster here. So air coaster got a spring constant of 220 and damping coefficient of 100. So we're gonna put it here where we got the initial value, where mass is 1800 and beta is 100, and for the spring constant is 220. Here's the K value, 220. And yeah, we're gonna just run this, and here is the plot for air coaster. And next is we're gonna plot for cloud rider with the spring constant of 59 and damping coefficient of 1050. And the K coefficient is spring constant is 59. And this just gonna run this, and here is the plot for cloud riders. And last is we're gonna plot for extreme shocks with a spring constant of 170 and damping coefficient of 1110 is 170 and 1110. Okay, so we're just gonna run this, and here is the plot for extreme shocks. So that is for problem 2. And next is the problem 3, where we should discuss the model of each shocks, and we have to decide which shock is the best. So if we take a look at each shocks, here we go. First is if we take a look at air coaster. Air coaster is got damping coefficient is significant significantly under damped compared to its critical value, and it's leading to oscillatory behavior. And about the cloud riders got damping coefficient is over damped, which results in slow return to equilibrium. And next is the extreme shocks. Extreme shocks is damping coefficient is very close to critical damping. Uh, it's leading to optimal stabilization. So after describing all of these shocks, uh, the system uh, Shocks I will pick for STT suspension system for loading. Uh, I think I will pick Cloud Riders with the K or constant spring of 59 and damping coefficient of 1050. The reason why I pick Cloud Riders because because its low stiffness and very high damping provides the best vibration as isolation. As also, the Cloud Rider's shock's superior damping capacity makes it the optimal choice for ensuring the safety and integrity of the satellite during transportation on the STT. So that is the last problem for the instruction. And next is the B problem. So the B problem is asking about what is our opinion about the Elon Musk video. So from the video, we see that Elon Musk responds to the question about what would you ask on what would you ask an uh, woman AGI? What would you ask an woman AGI? So that is the questions from interview to Elon Musk, and Elon Musk answered it with it, and Elon Musk answered it with what is outside of the simulation. So this question really craves deep into the philosophy of this world. With little of my knowledge about the numerical method, I will try to provide an opinion regarding Elon Musk's answer. So in my opinion, asking what is outside of the simulation to an AGI is like asking human about afterlife, which is a thought that is difficult for both human and um, for human and a robot or AGI. So AGI or robots, in other hand, AGI is created by human and human is created by God. So with this terminology, Elon Musk asking AGI what is outside of the simulation is like God asking human what is outside of this world or afterlife. So that is my opinion about Elon Musk's video, and also that is my answer to the last problem or the B problem. So that is all for me. Wassalamualaikum warahmatullahi wabarakatuh.